All right, class, so this is an ALEKS topic that's called calculating molarity using solute moles. And this is a pretty straightforward topic, but there is a little tricky aspect to it because ALEKS is introducing these units of micromoles and millimoles. So I'm going to talk about that real quick. 1 mole, which is what we are used to using, is equal to 1,000 millimoles. And then this symbol here represents a micromole. So you'll have to sort of notice the differences between a micromole and a millimole. On the next example, we'll look at millimoles. And then 1 millimole is going to be equal to 1,000 micromoles. So I'm going to be able to use these sort of conversion factors to figure out what I need to figure out whatever units I need. So in this problem, we are given the fact that we've got 180 micromoles of potassium iodide in 400 milliliters of my volumetric flask. I'm asked to calculate the concentration in moles per liter. So we're looking for moles per liter. So really all I need to do is convert this micromoles into actual moles and then divide that by the total liters, the total volume. So the way that that would look would be 180 micromoles times 1 millimole over 1,000 micromoles. So this is just using my conversion factor here. And then I'm going to need to do another conversion to get all the way to moles, where 1 mole is equal to 1,000 millimoles. So my units of millimoles will cancel, my units of micromoles will cancel. And this gives me a value of 0.00018 moles. So that's just converting micromoles into moles. And this conversion for these types of problems, you're going to have to do a few times. Now, we're looking for the concentration in moles per liter. So this is my number of moles. And then my liters is going to come from my 400 milliliters, right? That's the total solution volume. So the actual moles over liters will just be 0.00018 moles divided by 0.400 liters. So that's converting this 400 milliliters into liters. And that gives me a value of 4.50 times 10 to the minus 4th moles per liter. So that is my answer. And it says round your answer to 3 sig figs, so we should be good to go with that one. I'm going to do one more example just to make sure we're all getting it. So in this example, it's a similar type problem. Chemist prepares a solution of potassium dichromate, measuring out 12 micromoles. But in this case, we're asked to find our answer in terms of millimoles. So again, I'll just convert 12 micromole times 1 millimole over 1,000 micromoles. My units of micromoles will cancel out, and that is 0.012 millimoles. Now, this 0.012 millimoles, that's the unit I'm going to be using in this case. So typically, we're going to be dealing with concentrations as moles per liter, but sometimes ALEKS is going to ask us to deal with other units. So here's my other unit. So 0.012 millimoles divided by 0.250 liters. So I'm asked for millimoles per liter. Oops, this should be 200. Scratch that, 0.200 liters. So 200 milliliters to 0.2 liters. And that should end up giving us a value of 0.060. So 2 sig figs, this would be 2 sig figs, millimoles per liter. So that's my answer there. All right, hopefully that makes sense.